So in this video, we're going to take a quick look at higher order derivatives. So this problem here says find the third derivative of f of x. And that just means take the derivative 3 times. And just notationally, we've been using this prime notation, f prime of x, to represent the first derivative. So in general, if you take the derivative of the derivative, so if we take d dx of the derivative, then we're taking the second derivative of f of x. So you start with your function f of x. The first derivative of f of x, take the derivative of the derivative, you get the second derivative. And the notation you use then is just f double prime of x. Here was f single prime of x, f prime of x, f double prime of x. So if we wanted to take the third derivative, we would just take the derivative d dx of f double prime, which would give us f triple prime of x. Usually once you get to 3, you stop using the prime notation because, for example, if you did the 20th derivative of f, you wouldn't want to sit here like this and scratching out a bunch of primes. So usually once you get past 3, so for example, the fourth derivative, you put a 4 in parentheses kind of in an exponent position. F4 of x would mean raise f of x to the 4th power, but f parentheses 4 of x means take the 4th derivative of x. You usually wouldn't do 4 prime symbols. It starts to get clunky. So take the third derivative of f of x. So here we start with f of x. And then we could take and rewrite this as 4x cubed minus, bring the x up into the numerator position by changing the sign on the exponent. And I'm going to use the rules that we developed in the previous videos for this homework, but I'm going to use them in a very shortcut fashion. That would be more like what a person would do it once they got comfortable with things. So if I'm taking the first derivative, I can see that I've got a constant times x to the third, so I know the derivative is going to be the constant times the derivative of the function. The power rule says bring the 3 down into the coefficient position, so I'm going to get 4 times 3 is 12 times x. Subtract 1 from the exponent, I get that squared. Here I have an x to the a form, so I can use the power rule, bring the negative 1 down into the coefficient position. I'll get a negative combining with this minus to give me a plus, and it will be x to the subtract 1 from this exponent, we get negative 2. So there's the first derivative. So the second derivative would just be to take the derivative of f prime of x. So muddle up my talking of this. So if I'm taking the second derivative of f, that would just mean take the derivative of f prime. Take the derivative of the derivative. So I look up here at the derivative and I take its derivative. I have a constant times x squared. I can use the power rule on x squared. That would bring the 2 down into the coefficient position. That 2 would get multiplied by that 12 to give me a 24. X, subtract 1 from the exponent 2, which will leave me with an exponent of 1, which you usually don't write. I'll go ahead and write it in this case. Plus x to the negative 2. This is in the form x to the a. So the power rule would say bring the exponent down into the coefficient position on the x, and then subtract 1 from the exponent. So negative 2 minus 1 is negative 3. This is the second derivative. I'm asked to find the third, so I'm being asked to find the third derivative of x, which means take the derivative of the second derivative. So I look at this. This is 24 times x. So it's going to be 24 times the derivative of x. And like we saw in the previous video, the derivative of x is just 1. So we said this is a special case. If we take d dx of x, we get 1. So I'm going to get the derivative of 24 times x is going to be 24 times 1 is just 24. Negative 2, I have a minus, a constant times a function, x to the a. Use the power rule. Bring the negative 3 down into the coefficient position. I get negative 3 times minus 2 is plus 6 times x, and then subtract 1 from the exponent. Negative 3 minus 1 is negative 4. So there's the third derivative of f of x.